Okay. I think what I need for my channel is a good Ukraine scandal. You know, I think that would get a lot of people watching. Like, what exactly is my connection with Trump and Ukraine? Nobody's asking these questions. You know, I think these are questions that need to be answered. You don't know how far this goes. You know, right? Definite integrals.
Oh,
so I think, Barak, you mentioned something in the last lesson which makes me think you might have heard of these before. Do you know what? Yeah. What exactly is this now?
Isn't this where you take the top one minus the lower one?
That's it. Yeah.
And then you substitute for x, or so, like you times it with the.
Well, what I think you nearly had a. What do you do when you have something written like this?
B minus a times f of x.
Not times. Not quite.
Substitute x's.
Yeah. So after you get the answer, so I'll call the answer capital F, you sub in the two values. No, the advantage of this method is it removes the C, and we'll see why in a moment. So just write that definition down first. Yeah. That's the next lesson. Yeah. Exactly what's the relationship with the graph? Hang on. Yeah. Okay, you got that?
Almost.
Got that?
Mm-hmm.
No. You can, for the next lesson, use it, but it is really not necessary for this lesson. Why does the C disappear? Let's have a look at an example, okay?
So why is there like capital F then small f?
I needed some way to show that this F is not the same as this.
Okay.
Because remember, this is the antiderivative. Usually in maths you capitalize to show that, okay? So I'll give you an example. Let's say 1 to 2 x squared. I'm going to show you why the C doesn't matter, okay? If you put in the C, you get, what's it, x cubed over 3 plus C. And then you put in the two limits, 1 and 2. So if you put in the 2, you get 8 over 3 plus C. And minus, and you put in the 1, and what do you get? And you're left with 7 over 3. So you do not need to even write the C, because it always goes. And I should have said, well, we mentioned it a few times, they're called limits. To be more precise, this is called the upper limit, and this one is called the lower limit. Okay? Let me give you a simple enough one to try, so you get the idea. So I just want you to try this one. Let's say we'll go with, let's keep it the same again, 1 to 2, 1 over x dx. Calculate that. Comfortable? Got an answer? 0.69? Yeah. Yeah? Continue. So this integrates to log x. So it's log 2 minus log 1, which is log 2, which is 0.69 something. Okay? Now, although this one is quite simple, there is a slight alteration I can make to this question for the exam, and it sometimes catches people out. What's wrong? Where's your calculator? That's a great place for it, isn't it? All right. Oh, I don't know. We'll just say something like 2x plus 4. No, plus 3. One to 2 again. I'm tired of 1 to 2.
3.
1 to 3 this time. So the question would be, calculate this as normal and express your answer in the form no, I've changed my mind. I don't like 1 and 3 now.
1 and 2?
No, let me think.
0. 0 and 0.
Huh? It can be anything I want it to be. And it
0
can be
0.
1. Oh, fine, 1 and 3. No, okay. What way do I want the answer?
Quadratic.
Log. Oh, sorry, let me just turn this off. Log. Cube root A. No.
Thank you.
Square root A over B, where A and B are natural numbers.
Where did x go?
Yes, where did x go? If you're putting in numbers, the x is gone.
Oh, true.
Yeah. Now, as you will remember from your mid-semester exam, quite a few of you, and by quite a few I mean all except one, screwed up this question in the exam when it said express your answer in the form of. Right? So, try again now, making sure your answer is in the right form.
It brings bad memories.
So if you get a decimal answer, it's no good. It's no good. Isaiah, off the phone. Now I hope you can write it in this form. I mean, I have to quickly do it in my head. I think it's possible to write it in this form. It is possible? Oh, good.
We think so.
Well, look, you're the one with paper and a calculator, not me, so. Yeah.
Oh, right.
We got answers?
Almost.
Yeah. So when you integrate this, you got 1 over 2 log 2x plus 3 1 to 3. Okay. But you remember from your rules of logs that power half goes inside as a power, right?
Yes.
And what's power half? Meaning? Root. Now let's put in our 3 and our 1. So put in our 3 first, we get log root 9 minus log root 5. With the root, sorry. And using our log second rule, this is log root 9 over 5. And of course, the mistake that you could make in the exam here is to write the answer as log 3 over root 5. But of course, you guys wouldn't make that mistake. You would make a different mistake. Because what you'll do is you'll type this in on the calculator.
Give us a number.
And the calculator will give it to you in the form of 3 root 5 over 5.
Interesting.
Yeah.
Why?
Oh, one at a time, hang on. So anyways, this is the only right answer because of how I asked the question.
A over B.
Some of you will think of simplifying to this, which will be wrong, because it's not what I asked for. And some of you will simplify to this, because you depend totally on your calculator for answers, and this is what the calculator will say. Right? That's what happened in the mid-semester. You all typed the quadratic formula into the calculator and wrote the answer down. Yeah. But you won't make that mistake again. Why the what? That's
Hopefully.
in the formula. The one I'm asking you to guess. The one I gave you. The one I gave you. Yeah? You got that written down?
Almost.
Yeah. Okay, so please, 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 in the exam, just be careful with things like this, okay? Yeah. Okay, you got that? Yeah? Can I scroll down? Yeah? Yeah? Okay. Now, let me give you a simple one to try and then another one. So, okay, just try that one. That's not too hard, just to practice, to warm up. You got that? Yeah? So this integrates to x squared over 2 minus 1 to 1. And this, it ends up being 0, doesn't it?
Yes.
It's 1 over 2 minus 1 over 2.
No.
No, sorry, class disagrees.
No, but
No, square,
but the minus
square,
one would be
square.
square.
Oh, dang. Okay. Right. Try this one. See what happens.
Log 0.
See what happens. No, it's not log 0, don't worry.
Oh.
Got an answer? What's the answer?
No.
Correct. Error.
Yeah.
You can't calculate this. Now why not? What was in my question that caused this error to appear later?
-1.
-1. Right.
Log -1.
Try this one now.
Same thing.
No.
Same
No.
thing. No?
Try it. It should be 0.69.
Not sure.
Yeah. Now, if you're getting the wrong answer, it's because you're using your calculator too much.
Yeah.
Did you get 0.69?
Exactly.
No, don't use your
You're not
calculator to
supposed
get
to
the
use it.
answer. This is log x, isn't it?
Yes.
-2 to -1. So you sub in -1, and then you minus, and you sub in -2. Did I get that right?
Yeah.
Yeah, oh, it's not 0.69, is it? Sorry. But anyways, it's the last one. Now, if you type this in on the calculator, you get the wrong answer, but that's only because the calculator is not as smart as you. Well, I guess it depends what I'm talking about. Anyways, kind of factorize, you simplify. So this will be log -1 over -2, which is log a half, which is 1 point something, isn't it? Or sorry, it's minus 0.69.
Makes sense.
Yeah. Anyways, this demonstrates my point I'm trying to make. In some situations, the integration doesn't exist. And it's not quite for the reason you think. So for example, here, when you all did this example, you thought the cause of the problem was the -1.
It's not.
So then when you went on through this problem, you would have thought, well, this is doubly bad because it has 2 minuses in it. Okay, but it's not the minus that actually breaks the integration. Does anybody know what it is that breaks the integration? It's not the minus here, because you can see in this example, it's fine with the minus. So does anybody know what is breaking the integration here? Oh, I see. Okay, nice try. Not quite.
The log formulas, log rules.
No. I suppose my question is, can anybody spot? Because I could have known at the beginning that this one doesn't work, and this one will work. I could have known this at the beginning without calculating it. It's something about these values and this function.
There's one positive and one negative.
Yeah, go on. Yeah? No, actually, that's not the problem. The minus isn't the problem.
There's one positive, there's one negative.
No, she tried that. It is something to do with the domain. So the problem is this. When you look at the function 1 over x, what value are you not allowed to use? 0. Technically speaking, when you're integrating, although it only becomes clear in the next lesson and in the coursework, when you're integrating, in some way you're moving from -1 up to 1. And in this situation, you're crossing a point you're not supposed to use. So when you go from -1 to 1, inevitably you'll pass through which point? 0, but you can't use. However, here, when you go from -2 to -1, do you cross 0? No. So, this guy here is called an improper integration, and this guy here is called a proper integration. Impropers are bad because they have you using values that you're not allowed to use. So I'll give you another example of improper.
What about the...
Yeah?
It's the same. The x.
That's fine. That one's fine.
It's like, it doesn't work with 1 over.
Because it's 1 over, yeah. I'll give you another example. Look here. So suppose I have something like minus 2 to 3 root x. Proper or improper?
Improper.
Improper. From the very beginning, I'm using values I'm not allowed to put into the root. Improper. Okay. What about minus 2 or minus 3 to minus 1 root x?
Proper.
No, improper.
Oh, yeah,
No, it's even worse. Everywhere is improper.
Sure. You
Right?
can put negative in the square root.
Yeah, exactly. Okay, you see what's happening here? What about 0 to 3 root x?
Proper.
Proper. Okay. What about 2 to 10 1 over x dx? Proper. Yeah. And then minus 2 to 10?
Improper.
Improper. You see what's happening here? Yeah. Let's try cube root x dx. Minus 1 to 1.
Improper. Proper?
No problem.
50-50, which are you picking?
Proper.
Proper.
Yeah.
You're allowed to get the cube root of negative numbers. You're not allowed to get the square root of negative numbers. You're allowed to get the cube root of negative numbers. Yeah, can you see? So this is possible, yeah, to get the answer. Yeah, so what do you do for this one? You should change it into a power. And then, you know the story, increase the power by 1, divide by the new power. I think this one works out to be, yeah, 6 over 8, 3/4, is it? I'm confused. You put in 1, you get 3 over 4. You put in minus 1, you get minus 3 over 4, isn't it?
Yes.
6 over 4. Yeah, 3 over 2. Did I make a sign mistake? Oh, sorry, I did. That's a positive. Sorry. So, it's 0, yeah. Yeah, thank you. I forgot. Remember, the 4 is even. So the sign goes away. Yeah. Yeah, it's because of the 4. Okay. So for one of the exercises, we have more examples to do, but for one of the exercises, I just ask you to state if it's proper or improper. Okay. Right, next question. I want you to try this for me. Oh, sorry, do you need to write that down? Go on, quick.
So only in square roots it can have a negative number.
Yeah. Okay. You got that? Yeah? Yeah? Now, let me give you kind of a trickier one to try. Can I scroll down? Yeah. So what's happening here, I'm giving you the answer. The answer is 1. I'm giving you one of the limits.
We need to find the other one.
But I need you to find the other one. Now see if you can do that, and I'll do it in a moment. The answer will be a decimal, okay? So 3 significant figures as normal. two answers? Yeah. I've seen this one in the exam a couple of times recently. You got an answer? How many answers? Ooh. Might have made a small mistake. I think they're a little bit different than what I was thinking. Got two answers? How big is the bigger answer? Yeah, that's what I thought. Yeah, and say again? We'll talk about that in a moment. Right, let's. We'll have a look now. We'll have a look now. Look up. Look up. We'll have a look at it now. Yep. So, we'll have it, guys. We'll have a look at it now. We'll have a look at it now. So, we know the story. Increase the power. Divide by the power. And this one here?
4x.
4x. And the limits are 1 and t, and this should equal 1. So let's put the t in first. 3 over 2 t squared minus 4t. Let's put the 1 in. 3 over 2 minus 4, and that should equal 1. So that's 3 over 2 t squared minus 4t. With this one or without it? Okay, so plus then minus 1 equals 0. So that's 3 over 2 t squared minus 4t plus 3 over 2 equals 0. Yeah? Which is 3t squared minus 8t plus 3 equals 0. And this guy here has two solutions, 2.22 or 0.451. Now, what are we thinking? Do we take both or not? What's our thoughts here?
It has to be 2.22.
No, only the one that fits.
Yeah, so, well, I think everybody is happy with taking this as the answer.
It has to be bigger than 1.
This is fine. Yeah. And then this one here, we're saying
It can't be.
we're saying smaller than 1,
So it can't be.
so it can't be.
Yeah.
No. We can take this one too.
Nice.
So, the reason is, I never said that this number has to be bigger than this. It just usually is. But there's no problem with the top number being smaller. So this here is fine. There's no rule that says it can't be this. There's no problem with this at all. There's no problem made by subbing this in and then subbing this in. The upper limit could be 0.451. Just because it's called the upper limit doesn't mean it has to be more than the lower limit. You're allowed to have it. Yeah?
Why did you time by 2?
Where? Oh, I didn't have to. Yes? In fact, there's a simple rule if you want to swap the upper and the lower. Yeah, AB fx dx is the same as minus BA fx dx. The only effect of swapping them is changing the sign. That's all. It's no big deal. Yeah? Like this one? Yeah, there is this one. If you integrate from A to C, that's the same as going from A to B plus B to C. So you can take two integrations into one if you have the right limits. So if I said a problem like this, integrate 1 over x 1 to 5 dx plus, and then the same thing but 5 to 10, and the same thing 1 over x dx, you're allowed to do just 1 to 10.
Do we need to know? Or is like next lessons or what?
No, it's just useful to know that you can put them together and split them. So likewise, if I had 1 to 10, I'm allowed to split that from 1 to 5 and then 5 to 10. You know, I mean, you might say why, but I'm just telling you that you're allowed to do that.
It should be 5 or it can be like
No, it has to be. This guy has to be where this guy finishes. Yeah. I kind of think that's actually worth writing down. What do you mean factorizing? Oh, you mean if there was a number here? You're allowed to take that out. It's just a multiplication. Yeah. Yeah, so if you look, if you had a fx dx, you're allowed to take the a out in front. It's like factorizing, factor out. It's a multiplication. Yep. You got that?
So academic skills will be with the physics today.
Say again?
The academic skills will be with physics today.
Oh, I'm sorry, I'm so tired I can't process your sentence. A little slower.
Will the academic skills be with the physics?
Ah, yes.
Okay.
Is this a problem for you or for them?
No.
I'm just curious. Okay, you got that? Yeah? Okay. So let me give you some to try here. 1 E F G, 2 E F G. No, I don't want this. I want only English, okay? Okay, or look, you'll be like this guy. Look how sad he is sitting up in front beside me, okay? Alex, do you want to be sitting here? I didn't think so, okay, so be good, please. Right, 3. We'll say A. Fine, AX. And then 4, AB. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah, we do in the morning, don't we? All right, get a start on these now, please.
Wait, what?
Get started. Question?
Yeah, I still didn't get, like, I know, like, we get the half from here, but
Yeah.
why?
What do you mean why? Where's the rules?
Which one?
The rules I gave you earlier today. Huh? Do you not have them on your tablet?
Yeah.
Let me close this.